Hello everyone and welcome to our latest podcast, Reimagining Mobility. I'm here with Chris Meszaros, supervisor for AVL. Do you see a big challenge that if, let's say, we go to immersion technology, how you explained it, that then we're limiting the capacity of a module because now we need more space for the fluid?
That's a trade-off as well. And that's even a trade-off, though, currently with current conventional cooling technologies. Okay. They typically have a cold plate, which is basically a hollow plate, if you will, that the cells are then in contact somehow, usually through a thermal paste or a thermal pad. That metal that makes up that actual cold plate, that's taking up volume, right? Mm-hmm. So theoretically, you can eliminate that metal, you can take that space up with fluid, and you could potentially get some energy density back because you don't have the physical cold plate itself, right? Okay. So,
and that trade-off, we've constantly now talked about trade-off, thermal management trade-off, depending on what you want. Is how much does a technology company like us, like AVL, drive what this, let's say, this balance is, and how much is the customer driving this?
So I think one of the big things that sometimes our customers miss, and this is not such a problem with conventional tech, with EVs, these systems are significantly more tied together. So everything, the vehicle as a system, everything functions together. With a car, it is like that, but it's not so much, right? You have the same vehicle platforms with multiple engines that are in them, and these engines have different cooling capacities and cooling capacity needs, right? Mm-hmm. But they all have essentially the same frontal area, so on and so forth. With an electric vehicle, it's completely different, right? You need to look at the whole system and take a systematic approach. So I think that from our perspective, I think that sometimes we help make the customers aware of that, right?
Of the whole system.
Of the whole system, mm-hmm. that you can't look at just the battery pack itself and just the cooling, the in and out of the battery pack and say we're good, right? Yeah. It's an overall system.
Okay. Where do you see battery technologies, or specifically thermal management, go over the next 5 years?
It's hard to say. I kind of equate it to the way it was, let's say, in the 1920s, right? Where we had air-cooled engines, mm-hmm. and now everything's obviously liquid-cooled. Not everything, but most things are liquid-cooled, right? Yeah. I think we're kind of at that point in technology development, but whether or not we'll see significant changes over the next 5 years, I don't know.
What about materials? I mean, I've heard from many companies that have approached us and says, hey, can you help me with some of my resin, some of my plastics, some of my whatever it might be, just not metal as
there's a lot of materials, a lot of companies that have these, I'll say, latest and greatest materials, right? Phase change materials are a big thing where they're able to maintain, let's say, a liquid state to help the heat transfer when it's needed, and then if they get over a certain point, they solidify and they turn into a resistive element that blocks the heat transfer. I think that's probably the greatest development that's going to happen over the next 5 years is integration of some of these new materials into production solutions. Okay.
And from a thermal management, again, technology, methodology, tricks, whatever you want to call it, do we see a continuous improvement over the next 5 years? Is it exponential, or is it sort of, we're getting to a point where now we're not gaining anymore, in leaps and bounds?
I would say it's probably continuous and linear. Okay. There's still a lot of things that are being done for cells and how the various coolant medias interact with the cells or interface with the cells, right? Okay. For example, bottom cooling is really prevalent on a lot of things. There's some side cooling out there with cylindricals. There's really not a lot of side cooling with prismatic cans or pouch cells. I think you're going to start to see some of that. Okay. So I don't think it's going to be exponential. It'll probably be more linear, but I think it'll certainly continue to improve.
Okay. Does anything change when we talk, now we're talking more and more of a cell to pack or even cell to chassis. Is anything changing with that?
It does, because it changes with the thermal system, and by thermal system, it's not just the coolant, but the coolant is a big part of it, right? Things like how the car and how the battery pack or even the module, how they're produced, where the various checks for the coolant system to prevent, to make sure things aren't leaking, where those happen change significantly if you go from a module to a pack or even a battery solution into a chassis. Mm-hmm. So there's a lot of change that has to be considered from a manufacturing standpoint, tooling, how you actually execute. You talk cell to pack, there's pros and cons to each, right? There's a pro that you have more energy density. The con is a lot of these cell-to-pack solutions, you get a lot of the cells in the pack, and until it's fully assembled, you can't really do any of the checks. If you do the checks, now you got to pull the entire pack apart if you can, or you got a whole pack that's scrap, right? Whereas with a module, you don't have that. So,
Okay. Maybe a last question. I'm always been amazed of hearing how different companies deal with, let's say, the battery pack conditioning, right? So my car is at the airport, I'm gone for 2 weeks, and I'm in Michigan. And let's say typical Michigan weather, one day it's 50, the next day it's literally a negative 20. The battery is consistently working even though my car is parked, right? How much is your work involved with figuring out how to do that?
my work particularly, so I'm more in charge of the design, the mechanical design and the integration. I don't get involved in as much of the software aspect. That's more handled by like the software, the battery management system. We have obviously the capability in-house to do that. I don't get involved with that, but that kind of goes back to my statement earlier about it being a systematic approach, right? There's more than just flowing coolant over a battery cell and making it cool at all times, right?
And more than when it's being driven, also when it's sometimes
right.
again.
And we think of it as typically, when I think of thermal management, it's heat dissipation, right? But it's not always that. Sometimes you want to warm it up as well, right? Heat retention. So.
Chris, any final thoughts as it relates to where do you see thermal management, your team? What is the biggest thing that they'll need, and what's the biggest thing they're going to work on in the next 5 years?
Materials, manufacturing capability, I think, is the biggest thing, right? Well, a lot of the solutions that we work on are for mass volume, and how we enable that. There's a lot of carryover from, let's say, consumer electronics, computers and whatnot, but some of those processes aren't adapted to the size and the scale that we need, right? So those are the key things that are going to be enablers that are going to either make or break, solutions over the next 5 years.
Very good. Thanks, Chris. Very insightful. Appreciate your time. And thanks for tuning in.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.